Welcome to Math Solve. In this video, we are going to look at the sine rule. What is sine rule and why we need to use sine rule? In order to explain the sine rule, I am just putting here three questions and that helps us to understand why we need to use sine rule. Then we will try to figure out the sine rule to prove the sine rule. Okay. So I will come back sine rule later, but now look at three example here. The first one, you have the right angle triangle. You can see the box here, so it means it's a right angle triangle, and the one angle is given, and opposite of that is opposite, so which is 21 is opposite given, and then x is hypotenuse in that right angle triangle. So you can say, sir, this is the one that we can easily use the trigonometric ratio to get the value of x, right? And you know that trigonometric ratio you can just use because we have hypotenuse and the opposite. The relation between hypotenuse and opposite is a sine theta, right? So you can use sine theta, which is 33 degrees. Sine theta equal to opposite over hypotenuse, right? So katoa. So opposite is 21 over hypotenuse, which is x. So if I ask what is x, then you can just do x equal to 21 divided by sine of 33. And then if I use the calculator, you will get the answer. So it is 21 um, divided by sine of 33, and it is giving us 38.56. So if I leave it in two decimal, 38.56 in meter, because we are looking at the other unit is meter, right? So that's how you can get the this problem done. So you can get the side length by using trigonometric ratio, so katoa. But if you look at the other two examples that we have here, the next one, you have the angle and then opposite arm is here, which is unknown, so we have to find out that arm. Okay, and here we have the angle and the arm given. So this angle, this angle is associated with this arm, right? So the angle and arm, associated arm given, and but other angle is given, but its associated arm is not given. So I always try to write in an arrow, so you know that this angle relates with that arm. So if you look at the third example, you have the angle and arm. So in this case, the angle is unknown and its arm opposite of that angle is given, and then angle 83 is given and its opposite arm 10 is given. So angle and arm given, but the other pairs, you have only length given of the side, but its angle is not given. So it means for this problem you cannot use the trigonometric ratio. Why? Because trigonometric ratio is only applied for the right angle triangles, and if you look at these two examples, then these are not right angle triangles. So in this case, in these situations we need to use the sine rule. So sine rule actually telling us what could be the relation between the angle and its arm with the another pairs. So you know that each problem we have four parameters: angle, arm. So two angles, two sides, but associated sides, and out of that four parameters, one will be unknown. So in this case, these three given, and one arm is unknown. In this case, two arm is given, but one angle is unknown, right? So one angle is unknown here and one side is unknown here. So now we have to find out the way to solve this problem, right? And this can help by getting sine rule can help us to solve this problem. So now we are looking at the sine rule first. How the arms and the angles would be related, we will find out the relation by explaining the sine rule. Then we will come back to this page to solve these two problems. So in order to explain sine rule, we'll start with a triangle. Let's say that we have a triangle with A. This is the angle A, and opposite of that A is lowercase a. B, capital B is the angle B, and then opposite of that is lowercase b. And then we have capital C is the angle C, and then opposite of it is lowercase c, right? Now we can so we need to find out the relation with the arms with its associated angle, right? So in order to do that, first we need to make a vertical line on it from C to let's say we are making a vertical line. Let's say imagine it's a vertical line, CD for instance, and if it's a vertical, then this side is 90 degree, other side is also 90 degree. So let's say we are talking about the left side right angle triangle. So we have a right angle triangle, okay, which is ACD, okay, and if let's say vertical height is H, we don't know what is H, right? So we can write down in terms of SOHCAHTOA, that if I say sine of A, if I talking about the sine of A is opposite over hypotenuse, and opposite is H over hypotenuse is B. And if I just do H equal to B sine A, I am just rearranging that equation, right? Okay. This is in triangle ACD. We are talking about the sine of A, that angle, right? Now, if you look at that another triangle, right angle triangle, which is the right side one, CBD whatever, or DCB or DBC, okay, or CBD, okay, sine of B, if you are talking about this angle, opposite is H, we are talking about the right angle, right? So H over hypotenuse is A. So opposite over hypotenuse, right? Then you can write down H equal to A sine B. So it means both H equal to B sine A sine B. So can I write down A sine B equal to B sine of A? So the first one and the second one is same, right? So if I do that, you can rearrange this one and write down A over sine A equal to B over sine B. So A sine B, and B sine A if you do the cross multiply. So we can rearrange it like that. Or if you want to write down the angle on the top, sine A over A, then you can write down sine B over B. So what you need to make sure that when you are writing angle on the top, you have to write down the angle on the top for the next part as well. Okay, then it would be the same. And what I would recommend most of the time, if the question is giving you asking you for arms, I would write down the arms as a numerator. It's easy for calculation. If the question asking for angle, I would write down this form, then angle is on the top. That's easy. So and then same way you can prove that B over sine B equal to C over sine C. So basically A over sine A equal to B over sine B equal to C over sine C. We don't need all these 6 parameters because the questions is mostly giving you the 4 parameters. Out of 4 parameters, 1 will be unknown, 3 will be known. And in these problems you will see that we will have 2 angles and 2 arms problem. So it means we have that 4 parameters, 2 angles, 2 arms. Out of that 4 parameters, 1 will be unknown, and that you need to find out. And remember that angles and arms should be the associated one. I mean the angles with the associated with this arm. So it's always the opposite one, right? And now we will go back to solve the problems that we started with. Okay, let's start solving the other 2 problems now using the sine rule. And as you can see, now we have the angle associated with the arms and the angle associated with the arms, and only out of that 4 parameters we have that side is unknown. So we can just straight away write down the side over sine of that angle equal to other side over its angle, sine of its angle 75 degree. And now if I just make x subject, it will be 7 sine of 80 degree over sine of 75 degree. And in calculator, if you press, just plug in the values in calculator, 7 sine 80 divided by sine 75, so it will give us 7.14 meter, right? And the same way you can do the other one. In this case the theta is unknown, so we can just put theta on the top, so sine theta, and its arm is 9. And so you see we are not putting a b c. We don't need to do like a over sine a, b over sine b, as we know that the relation is angle with the arms, right? And the next one is sine of 83 over, so it's 83 over 10. And if you just make sine theta equal to 9 over 10 sine of 83 degree, and if you do the calculation, sine of 9 sine of 83, sine of 83 divided by 10. So it will give us 0 point, so it's basically sine theta, which is 0.8933, 8933. All right. So make sure it is sine theta, is not theta. So what we have to find out theta. So what you can do, you just need to do sine inverse of that value, right? So we used to go shift sine. So I can write down for you just sine inverse of 0.8933. As you know that this value you are going to use for next calculation, I would like to keep more decimal places to make it more accuracy, right? Now you just do shift sine, shift sine of answer, which is give us 63.29, 63.29 degree. So you see you can get the degree. Now you can probably think, can you do the first problem using the sine rule? Obviously you can do. As you can see, you have the angle with the opposite arm is given, and then that unknown side we have 90-degree opposite angle we know already. So you can obviously write down in terms of sine rule. So you can say x over sine of 90 degree equal to 21 over sine of 33 degree. But you see, sine 90 we know it's 1, so x over 1 is means x, so you can just write down x equal to 21 over sine of 33, which is exactly the same here. So if you do the calculation, you will get 38.56. So you can obviously use the sine rule as you, if you have the angle with the opposite arm relation is there. But if it's a right angle triangle, I mostly prefer to go with the SOHCAHTOA, I mean the trigonometric ratio, unless it is not the right angle triangle, then you have to use this one. Thanks for watching. Please subscribe my channel to see more up-to-date videos.